The first step is to determine whether or not the system is operational during daylight hours. DC optimizers use a color-coded LED on the inverter to indicate the health of the system. A flashing green LED on the inverter points to a grid failure on the AC side of the circuit. That is to say that while the system senses voltage from the array, power from the utility is either not present or not within the specification of the system. This could mean that there is no power from the grid, that the voltage is too high or too low, or that the frequency is not within spec. The first thing to check in this case is whether the AC disconnect is on or off. The next thing to check for is the inverter breaker to see if it has been tripped. The inverter breaker will be located at the bottom of the main service panel on a load side connection. If the main system breaker has been tripped, the first thing you should do is make sure that it is sized correctly. First, determine the inverter AC output power, in this case 5,000 watts. Then divide that by the nominal AC voltage, in this case 240 volts. The resulting value of 20.83 amps is the maximum current that can safely flow through the system. A breaker smaller than this would trip under peak power conditions. Per NEC 215.3, the breaker size is determined by taking the current value, multiplying it by 1.25, and then selecting the next larger breaker per 240.6. 20.83 amps times 1.25 equals 26.03 amps. The next largest breaker size is a 30 amp breaker. Once you have established that the breaker is tripped and that it is sized correctly, the next step is to identify the fault on the AC side of the circuit. To do that, first turn off the AC disconnect. Then go to the PV sub-panel and using the multimeter set to resistance, measure the various conductors line 1 to line 2, line 1 to ground, and line 2 to ground. Isolated conductors attached to the sub-panel should have very high resistance in the mega ohm range, or read OL for open loop. In this case, you can see that all combinations of ungrounded to ungrounded and ungrounded to ground yield an open loop condition. What this means is that the circuit is sound on the AC side. The next step would be to close the AC disconnect and retake your resistance measurements. If this repeated test yields open loop again on all possible combinations, then what you may be dealing with is a bad breaker. I would recommend replacing that breaker and recommissioning the system.